Hello, Math 126 students. I'm going to talk about what's likely to be on pages 5 and 6 of your final, which typically that pertains to chapter 15. So what I did here is I went through the 4 most recent finals and I saw I looked at what I found on pages 5 and 6. So the most recent exam in the archive, there was reverse the order of integration and set up a double integral. There was a question about setting up a double integral for the area of a polar problem. There was a question about the reversing the order and setting up the bounds. There was a question about center of mass over a rectangular region. There was a question about setting up volume. There was a question about setting up a volume with polar. There was two questions about setting up volume. So this is really about, to me, chapter 15, it's very clear what the question's asking, but can you execute? So let's go through and just talk about double integral concepts. Make sure you don't miss anything. So we learned this tool for measuring what's happening over a region. And remember that it required 2 things, a region and a surface. And I've tried to say that lots of times, so you had that in your head. These 2 separate things. You have some region on the ground, R, and then you're going to have some surface up here. And ultimately, we found the double integral can be visualized as this volume, but it computes other things. Okay, so you need these 2 separate things. We also talked about how if you integrate one, it ends up just giving you the area of the region. Okay, I like to think of chapter 15 as all the questions are the same. So step 1 is what's the z? So if you have a problem that has multiple z's, we talked about what happens, if you had something like x squared, I don't know. You had a cone, and then you had some other surface. I don't know, the square root was the one we had in the homework. That was something like this. X squared. I just wrote the same thing. If there were multiple surfaces in the problem, I think you had this one that was the volume between a cone and a sphere. But step 1 is you go, okay, those are my double integrals. dA. And we did several examples over several days for different situations. Okay? So if there's multiple z's, unfortunately you have more than one problem to do. Then you're going to draw the region. So you draw any given xy equations. For example, if it says x equals 1, I don't know, y equals 0, x equals 0. You would graph all those things. What did I say? X equals 1. X equals 1, y is 0. And in that situation, you go, well, there's not enough information. So either they need to give you more information, I don't know, like y equals 3x, in which case you could graph it, and then you could shade. Or maybe the surfaces intersect themselves, and we saw some examples where that happens. So if that happens, if you go to draw and you can't find, then your job is to find when the z's intersect. Okay. So find when the z's, so for example, if you had z equals x squared plus y squared, and you had z as, what else can I think of? Well, how about z is this, and z equals 16. If the question said find the volume between these 2 things, so first you would have these 2 problems, 16, and you'd have the double integral of x squared plus y squared. And then when you go to draw, you would say, well, they didn't give me any equations, and so you would find the intersection of these 2, which is a circle of radius 4. And what's happening is you have this circle of radius 4 on the ground, and you have these 2 different surfaces, z equals 16 and this parabola, and you're trying to find the volume between them. But all that really matters is you're integrating over a circle, so then you would set it up in polar and then compute and subtract. Okay, so once you have this region drawn, then you have these 3 options for setting up that we talked about. Okay, if you're suspicious that it might be polar, convert everything to polar. If you're having trouble drawing the region, just plot points. That's it. Now we did have one application you do need to be ready for. It's center of mass. Now, the main thing I like to tell students concerning center of mass is you should put a few things on your note sheet so you just don't forget. So the main things you put on your note sheet is these, if you've forgotten, but that the density is proportional to the distance from the origin, means the density is K times this. So I would put that on my note sheet in case I forgot. I mean, you can remember proportional to distance from the origin. That's what that means. But and then if it says the density is proportional, and I'm just trying to think of things I've seen on old test and on the homework, to the distance from the x-axis. Now in that case, if this is your x-axis, your distance from your x-axis is y. And so this means the density is K times y. And what are the other ones I can think of? The density is proportional to distance from y-axis. That means this. If it says inversely proportional, then you flip this function. So inversely proportional would make it 1 over the square. So I would just add those wordings. Yeah, the reason I say that is it's hard to get started if you don't know those things, and that's what goes in these spots. And then the rest of the problem becomes drawing the region they describe, plugging in your bounds, and computing. So it's mostly a computational exercise. Let's take a peek. I've just been finishing these videos by clicking on random old finals. So let's look. Many years ago we used to do things in a little different order, so it may not be on exactly the same page. Those are Taylor polynomials and series questions. Okay, here we have a center of mass. In this case, they gave me the density. Compute the mass. Oh, it just asked for the mass, and so you only need to compute the double integral of that. So I don't know if there's. Oh, I was going to keep looking at the other questions. Let's click on another one then. It's bad when I go this far back because things are in a different order. Line of intersection, tangent plane, that's for chapter 14. Ooh, what is this? This looks like an applied question. Oh, that's a chapter 14 then, so I'll skip that. Okay, so here's chapter 15. So your job in this question is to graph what it means for it to say that y is between 0 and 1, and x is between x equals the square root of y and x equals 1. So your first job should be to graph x equals the square root of y and x equals 1, which means y equals x squared and x equals 1. Then shade that region, reverse the order. Find the volume of the solid bounded above by this and below by this. So again, step 1, solve for your z's. That'll give you 2 double integrals. Step 2, draw the region, which will be when those two things intersect. Okay, what else we got? Tangent plane. Oh, did I click on the same one? Looks like I did. Curves, max and min. Okay, here's another one. So your job here would be to graph x equals 0 and x equals arctangent. Now you say, well, I don't know what arctangent looks like. You can also write it as y equals tangent of x. You say, well, I don't know what that looks like. Plot a few points. Picture doesn't have to be perfect, but you really need to draw the picture. Then set up the double integral. Center of mass, this time they give me the density. Find the y-coordinate of the center of mass. So I should be computing the double integral of y times this, divided by the double integral of this. And the rest of the problem will be figuring out what region they want and setting up my bounds and computing. Okay, let's leave that.